Welcome once again to Easy Math. Today we shall be looking at the chain rule. First of all, we are beginning with the derivation. We are going to derive the chain rule. Suppose y is a function of t and t is a function of x, such that the y, small change in y, small change in t, and small change in x are increments in variables y, t, and x. Then small change in y over small change in x will equal to small change in t over small change in y over small change in t times small change in t over small change in x. Now, as the small change in x tends to 0, small increment in y over small increment in x tends to dy dx, and correspondingly all the others. So we have dy dx equals dy dt times dt dx. That will be our chain rule. We shall be applying it to solve many reverse problems in differentiation, especially where we have a function inside another function. Example: suppose we have y is equal to 3x plus 2 power 4. From the chain rule, we first of all have to get our t. Our t is that function in the bracket, which is 3x plus 2. And when we differentiate it, we get 3, because the derivative of 3x is 3 and the derivative of 2 is 0. So we shall have y is equal to t power 4, where the t is the 3x plus 2. So dy dt will be 4t power 3. We subtract the power minus 1. So applying the chain rule, we have 4t cubed times 3, which is 12t cubed. Now, when we substitute for t, we put the t there. Our t was 3x plus 2, so we get 4 3x plus 2 cubed times 3, and we get 12 into 3x plus 2 cubed. You see that it's now very easy. So you do the same thing for however complicated the thing is. As long as a function is inside another function, the chain rule works. So we are looking at more applications of chain rule. Now we shall use the chain rule also to differentiate trigonometrical functions in which there is a function of x in them involved. For example, that one, y is equal to cos 2x plus 3. So dy dx will be dy dt times dt dx from our chain rule. So we first identify our t, which is 2x plus 3, and we differentiate it, we get 2. And our y will be equal to cos t. Dy dt will be negative sine t. The derivative of a cos is always negative sign. We shall derive this further in our example on trigonometrical function differentiation. I'll be looking at it in the next tutorials. So when we differentiate cos t, we get negative sine t, and when we substitute in our chain rule, we get negative sine t times 2. Substituting for t, we get dy dx is equal to negative sine into 2x plus 3 times 2. And our answer will be that negative 2 sine into 2x plus 3. As easy as that. So if we are to go to another example of trig, we have y is equal to sine. Same thing, we get the t, which is 2x plus 3. Differentiate it, we get 2. Our y is equal to sine t, dy dt is cos t. And we substituting in our equation, we get cos t times 2. And we substitute for t, we get cos into 2x plus 3 times 2. And our answer will be 2x plus 3. Thank you very much. Remember to like, share, subscribe for more math tutorials, and in case you have any questions, feel free to put it in the comment section. Thank you. See you in the next tutorial.